Hi everyone, today we are going to learn about trees. What is a tree? Tree is a type of data structure. Okay, you must have heard and learned about different data structures in before. That would be like a linked list. Linked list is a data structure, stacks, queues, arrays, and so on. Okay. Now, trees is not a linear data structure. We can think about this as a non-linear data structure. Some of them also call it as a hierarchical data structure. Hierarchical matlab hierarchy is just different having different levels. Okay. Now this is a type of data structure. And what is a data structure? Data structure is nothing but anything, or basically it's a structure to store your data. Okay. Now trees is a very important data structure from point of view, its applications, okay, from your interview perspective, and you would also use this in more and more in industry. Okay, now trees can be thought of something like this, right? This is a tree. Okay, I might have data stored here, some numbers, okay, some integer data stored in it, and I can call this particular structure as a tree. Okay, now trees, basically there are different types of trees. Okay, we are interested more in binary trees. Then the second one is binary search trees. This S stands for search. Okay, we are interested in these two more trees. We have another kind of trees which is also called as n-ary trees. This is not much asked. Okay, you should know a little bit about this, but it's not very important. But these two is very important. Okay, now this example which I had given, this is an example of a binary tree. Okay, now why binary tree? The word bi means two. Okay, you must have seen this in number system also. We have a number system which is called binary number system. There also, why it is called binary number system? Because we have the numbers are made up of two digits, 0 and 1. Okay, here the term of binary is because every node, can you see this? This is called as a node. Okay, every node of the tree will have at max, okay, matlab maximum there can be two children. This is the left child of this node, and this is the right child of the node. Okay, so a binary tree is a tree where every node would have at the max how many children? Two children. So suppose if I have a scenario like this is also a binary tree because how many children does it have? This particular node has how many children? It has one child. How many children does this node has? It has 0 children. Okay. If I have like this can also be considered as a binary tree. This has one child. This is called as has 0 children. Okay. If I have something like this is also a binary tree because every node at maximum will have how many children? Two children. I hope you get that right. Okay. But if you have something like this, yeah, this is not a binary tree. The reason being this node has how many children? Three children. And this is not a binary tree. You can think about this as an n-ary tree, where this n basically decides how many nodes a particular node in the tree can have at max. Okay, so in this tree I can call this tree as a 3-ary tree because at max might be there are three nodes or three children for a particular node. Okay, what we are studying about is a 2-ary tree, yes, which is a special name called as a binary tree. Is this understood? Now there are certain terminologies which you should know when it comes to trees. Okay, and especially, and this is valid for a binary tree and also for a binary search tree also. Okay, now if I draw a tree like this starting node, okay, this is called as root of the tree. What is this called? Root of the tree. Okay, I can think about this as levels. Okay, I can name this as either level 0, this can be level 1, this can be level. Okay, sometimes if you can also in some of the questions it will be mentioned to you, sometimes they also level start the counting from 1. So if this is 1, then this is 2, this is 3. So this depends upon question. In the question they'll tell you how are they considering the counting. Are they starting from 0 or are they starting from 1? So what it means is, suppose if I'm talking from level 0, how many nodes are present at level 0? There are basically, let's change the color, they are present basically one node. In level 1, how many nodes we have? We have two nodes. In level 2, how many nodes we have? 1, 2, 3, 4. We have 4 nodes. Okay, so this is a concept. So this, the main is called as a root of the tree, and we have how many levels here? 1, 2, 3. Total 3 levels are present in this tree. And this is a binary tree because at the max, every node has how many children? 2 children. Okay. Now, the next concept which you should be aware of is the children. Let's change this to white. Okay. This is the parent. Parent of whom? Actually parent of the entire tree. Okay. But the direct parent of this node and this node. Right. Let's have this numbers here 2, 3 and 4. Now 3, this particular node which has data 3 is basically the left child of the parent node 2. This is the right child. Okay. Now this node, let's give the value of 5. This 5 is what? Left of the node number 3. So this is again the left child of whom? The parent node 3. Okay. The node number 2 becomes the grandparent for the node 5. Okay. Another name we had just taught about was root. What is root? Root is the starting point of the tree data structure. Okay. यहाँ पे जो भी data होगा will be called as a right child. So what you know, in a tree, at max, there will be 2 children for every node in a binary tree. The left child is called the left child, and if the right one is called as the right child. Okay. There's another term which you should know about. Suppose if you have a tree like this. Yes. And let's say this part is there. Okay. I can think about, this entire part, I can call this as a left subtree. And I can call this as right subtree. Okay. And this is your root node. Okay. What is this? We just saw this is a right node. This is a root node. Okay. And then we can think about this entire thing as what? Left subtree. Why left subtree? Because you can see this is a tree who has this node, root node at here. So this is a left subtree. This is called as a right subtree. You should be just aware of this term so that when they're asked in the question, you should be able to make sense of it. Okay. So we have let's recap what we have done. We have understood what a binary tree is. Okay. Then we have realized what if I have to talk about a binary tree is nothing but it is basically a tree which has at the max 2 nodes, right? So one which is on the left is called as the left child of the tree. Left child, otherwise it's a right child, right? Then we have talked about a concept of level. What is level? You can talk about this as one level. This is level 2. This is level 3, right? So either you can start your counting from 0, 1, 2, or you can start your counting from 1, 2, 3 for the levels. It depends upon the question what they're asking. Okay. Then what the starting node of any tree is called as what? Root of the binary tree. Yes, I hope this is clear. Now let's talk about the concept of height of a binary tree. Okay. So see, height of a tree. Okay, what is a height? Height, we know, right? We can talk about our height is 6 feet, 5 feet, 4 feet, so on. Correct? Now, when it comes to the context of a tree. Okay, let's say this is a binary tree. Okay, I've just written the short form BT. Height is basically this. This is called as the height of a binary tree. Okay. Now the height can be given in 2 terms. Either you can talk about the number of nodes, okay, which is basically starting from the top, the root of the node to the lowest child, right? For example, if my tree is going till here, then my height is going to be till here. So how many nodes I have? 1, 2, 3, 4. So I can talk about height is basically equal to 4 nodes. I've given it terms of 4. Otherwise, I can, basically count the edges in between. So this is one edge, 1, 2, 3. So I can also talk about this as 3, height as 3. Now, whether you take it in terms of nodes or whether you take it in terms of edges. Why edges? Because this is the edge which is connecting 2 nodes, right? So 1 and 2 is connected by an edge like this. So I can either say the height is basically 3, or I can also mention the height as 4 nodes if I have to give in terms of the nodes of the tree. Again, whether to use the terminology for nodes or whether to give the height in terms of edges depends again upon the question. That will be mentioned to you in the question, but you have two different ways of mentioning the height. So what is in height? Let's take some more examples to get it more understanding. Right? Let's talk about T1, T2, T3. Height is nothing but starting from the root. What is the lowest child you have, right? The depth is still here. So from here, if I have to mention the height of the tree in terms of nodes, I can say how many is there? 1, 2, 3. So these are 3 nodes. Or in other words, you can talk about it as edges, 2 edges. Right? If you mention 3 nodes, it's basically 3 minus 1 is basically 2 edges. For this, what is the height? You start from here and the lowest is still here, 1, 2, 3. Again, the height is equal to 3 nodes, or you can say it is in terms of edges, 2 edges. What about this? We have height is 2 nodes, or we can think about it as 1 edge. Okay, I hope the concept is clear. Now, in theory, if I have to talk about a binary tree, okay, the maximum height, okay, of a binary tree, okay, with nodes, with total nodes, suppose equal to n. Okay, suppose if I have a binary tree where the total number of nodes in a binary tree are some value n, then you can give the height of a tree by log of n. Okay, you can give the height of a tree of log of n. Now there's a proper, proof to that, but we are not interested in theory because we're not giving a theory paper. But what it is basically, if I have, let's say, suppose if n equal to 3, right? So you can have something like this. Okay, so if it is a complete binary tree like this, I will have a height of log n. If this is a complete binary tree. Complete binary tree means there is a concept of complete binary tree. What is a complete? The C stands for complete. Let's take a different page. Yes, so let's talk about this concept of complete binary tree. Okay, a complete binary tree is a tree where every node has a left child and also has a right child. Okay, so if I have a node like this is a complete binary tree. But let's say if I just draw a tree like this is not a complete binary tree. Why? Because there is a missing right child here, and that's why I cannot say that it's a complete binary tree. If there was a right child here, then I could say that it's a complete binary tree, but there is no right child here, so I can say this particular tree is not a complete binary tree. But on the other hand, this is a complete binary tree. Okay, and the thing which we are talking about now in terms of height, when you have a complete binary tree of total nodes n, then the height is basically log of n. Okay, and let's talk about, and then if you have a general formula, if you have basically n nodes which make up a binary tree, not necessarily a complete binary tree, then the height of a node at max can be basically n. Why n? Think about this. Suppose if you have n equal to 4, okay? So what kind of binary tree you can have? Something like this, 1, 2, 3, 4, 4 nodes, or you can have like this 1, 2, 3, 4, or what you can do, what is the other way you can structure a binary tree? 1, 2, 3 and 4. So this is 1, 2, 3, 4. Any other way? Might be this side you put it. Yes, something like this. Or you could make it, I hope you got the drill, right? Or you can have one more part which is going this way. Right? Now these are different ways, right? Now the maximum height is basically n, O of n, right? Because 1, 2, 3, 4. So the maximum height of a tree, of a binary tree, okay, with n nodes is going to be n. You cannot go more than n, right? But if you have a complete binary tree, then might be the height would be around log n, right? If you see, this can be thought about as a complete binary tree, because complete binary tree, you start from here. Okay, complete binary tree is those tree where every node has a left child and a right child. Okay. And second thing, yes, this is not a complete binary tree, it's a partial binary tree, because there is this particular thing is missing, right? Here the right child is not there. Okay. But still this is a partial binary tree because the nodes are being filled from left to right. Okay. That means this I cannot say it's a partial complete binary tree, because this node should not have been filled. First you have to fill the left place, and then you can fill the right place. That's what it is for a complete binary tree. Okay, you do not need to know much about it. Only this much is important, that a complete binary tree is a binary tree where every node has a left child and a right child, and the nodes are basically filled from left side to right side. मतलब this इसको हम complete binary tree बोल सकते हैं, but this is not a complete binary tree, because if you have to make this a complete binary tree, then this needs to be here. Then it's a complete binary tree. Okay, but in this case this is already a complete binary tree. I had total 4 nodes, so I filled it here as my left child. So this can be thought of a complete binary tree. So the height with the nodes n, okay, you can have the height of a tree ranging from binary tree ranging from log n to somewhere around n. Okay, log n you would get for a complete binary tree, n you would get for a tree like this, right? This is basically called as a skewed binary tree. Why skewed? Because ये एक side पे झुका हुआ है, right? It's like this. So it's, the word is skewed. This is an English word. It's a skewed binary tree. Okay. Now this can be thought about as it is, you know, leaning towards the left side. I can call this as a left skewed binary tree. This can be thought about as right skewed binary tree. ये right side के लिए है, ये left side के लिए. ठीक है? इनकी height होती है O of n. I hope this is clear. So let's revise what all things you require to solve the concepts or questions of binary trees. What about, first about, what is a tree? What is a tree? A tree is nothing but it's a hierarchical data structure used to store data. Correct? Now tree, basically we can have different kinds of tree. Okay, the general thing is basically how many children every node has, that basically decides what is the type of tree. If you say that this n value is 2, then you can say that it's a binary tree. That means at max every node is going to have 2 children. Okay? So we are more interested about binary trees. Most of the questions in the interviews are mostly asked on binary trees. Okay? But let's say you get a question where it is a tree but the children are more than 2, then you can just, you know, expand your algorithm accordingly. Okay? Now the other concepts remain the same. That is, the start of every tree is basically called as a root of the binary tree. You should know the concept of level, right? This can be thought about as level. This is a level. Okay, you can think about this as levels in binary trees. Then we know every child, every root will have, or every parent node will have 2 children, left and right. Okay, this is the left child, this is the right child. Further ahead, you can divide a tree into 2 parts. This is your left subtree. This is your right subtree. This is your root node. Okay. What else? We have spoken about the height of a binary tree. Now, to understand the height of the binary tree, you can think about, you know, the concept of a complete binary tree. Complete binary tree is that binary tree where we try to give left child and right child to every node. Okay. And the tree is basically filled from left to right. So you go from top to bottom, left to right. मतलब अगर आपके पास 4 nodes है, okay, this is considered as a complete binary tree, but this is not considered as a complete binary tree. Why? Because ये नहीं होना चाहिए. पहले left child fill करो, उसके बाद you can fill the right child. That's what it means. Okay. Then we have talked about something called a skewed binary tree. Skewed binary tree, let's say for n equal to 4, will look something like this. Now for a particular number of nodes as n, and if you want to construct a binary tree, you can have at max the height of the binary tree would be n. And if it's a complete binary tree, you would have the height as log of n. Okay. So the height of a binary tree ranges from log of n to n. N in the case of a skewed binary tree. Okay. I hope this is clear. This is all you require when it comes to binary tree concept. Yes. Now let's go to our IntelliJ and try to model. Okay. Now suppose you have to write this in code. Now we will be using Java language today. Okay. But you can very easily, you know, try to replicate it in any other language like C++ or Python. Right. So now here we're going to try to see how we can construct trees. Okay. Using Java. Now there's one thing which we should talk about before we can go to the IntelliJ, and that is, see, when you're trying, this is a concept which we have heard, you know, which we just spoke about when it comes to trees. Now you have to model this or write code for this, right? Okay. To store trees, okay, we can store trees in 2 ways. One is you can use a classic way of classes and objects. Okay, that is your OOPS concept. Or you can store the tree using arrays. Okay, there are 2 ways of doing it. Now let's think about arrays. Suppose if I have a binary tree like this, which has 3 nodes, right? If you remember, arrays is a data structure. It's a linear data structure, correct? And if you want to use arrays, you should definitely know what is the size of the arrays you need to create. That means if you have to represent or store your trees using arrays, you should know how many nodes of the trees are there at the start, because that's going to help us to define the array size, right? Because array, we need to define the size of the array at the time of declaration itself. Okay. Now, for example, I want to store this. What I will do is I'll take an array of size 3. Okay. I'll store my root node here, left child followed by right child. So what is the pattern? You store your root, or let's call it as a parent node. After parent, you're going to store its left child and then followed by the right child. Okay. Let's try to take a little more bigger example. If I have 1, 2, 3, let's say 4, this is 5. If I have to store this, how many nodes I have? 5 nodes. 1, then go to the left, 2, right, 3, come to left, 4, 5. Let's say there was one more here, 6 and 7. So you would have then said 6 and 7. This is how you store. Okay, level by level, going from left to right. Okay. Now, when we know in the case of when it comes to arrays, we know the indices go from 0, 1, 2. This is 0, 1, 2, 3, 4, 5, 6. Okay, this is how usually your indexes goes. Now, when you're trying to store this, let's try to do an exception. What we'll do is, just for simplicity, we will say we will always leave the 0th index empty. We'll have some value which you're not going to use, and let's start storing the values of these trees from index number 1. 1, 2, 3. You will have 1, 2, 3, 4, 5, 6, 7. That means when your total number of nodes are n, you will create an array of n plus 1 size. Is it right? Because we are not using the index number 0. And I'll come to it. Why are we not using index number 0? See, let's say you are here. You want to know the left child of the node number 2. Where is node number 2 stored? At index number 2. Let's call it I equal to 2. To find out the left child, I could just say 2 into I, which is basically 2 into what is this 2, which is equal to 4. That means my left child 4 should be stored at which index? Index number 4. Is that the case? Yes. This is your parent. Your left child is stored. Did you get this? If I have to find out the right child, what is your right child of this node? Right child is 5. So actually you should get the value 5 here, right? Basically your A of whatever. This is your index, right? So what I'm going to do is right child will be 2 into I plus 1. In our case, 2 into I is, we have seen 2 into 2 is 4. Plus 1 is basically 5. So at 5th index, we have the value 5. Correct? That means we're using this, criteria of storing a tree into an array, but we start storing from index number 1 for that array. If you know the parent's index, let's say the parent index for a particular node is I, you can find the left child of this parent, immediate left child, by using the index of the left child would be 2 into I. The index of the right child would be 2 into I plus 1. Okay, because this works because you're starting with 1. You can use the same thing here as well, right? Here, if the index is 1, the index of the left child should be 2 into 1, which is 2. And let's see, at index number 2, the value 2 has been stored. Here, the right child should be 2 into 1 plus 1, which is 3. So at 3, this should be stored. Okay, and this we are not using. So you can fill this with any default value, or you can just leave it blank. Anyways, because it's an integer array, the default value would be 0 here. Yes. Okay. So this is how you would, want to store. If you want to store your trees using array representation, then this is how you would do it. If you have an index I, parent, the left child is at 2 into I, right child is at 2 into I plus 1. Given that, you start filling the tree from index number 1. Okay, let's say somebody is saying that I do not want to, waste that A of 0 space, the space 0. Then what will you have to do? Then you will have to everywhere subtract might be the values, right? Something you have to change these formulas accordingly. Okay, you can definitely start with 0, but then you'll have to change these formulas. And we don't want to make it complicated. It's not much of space that you are wasting. Okay, this makes your job very easy. So this is one way of representing your tree data structure using arrays in your Java. In Java or in C++ or in Python, you can use this. The another representation is using classes. Okay. Most of the time, we will use this representation to solve problems. In fact, when we solve problems on LeetCode and Geeks for Geeks, you will have mostly this representation which is used. Okay. Very few times we'll use a representation of arrays, but most of the time we'll use a representation of class. So let's try to see how to do the class representation, and then we can actually see both of the code in the in your IntelliJ, right? Now for trees, right? If whether it's a binary tree, we're talking about binary trees right now. Okay, so a node. Okay, so we can think about this as a node. Yeah, it's a node, right? This node should have what all things? It should basically have a pointer or a reference to the left child, correct? It should have a reference to the right child, right? And it should have the data which you are storing here. So if I think about this as a node, it should have what all information? It should have information to the reference to the right child, reference to the left child, and it should have the data which is stored in it, right? So I can bundle this together into a class called as node, correct? And I can think about trees basically made up of node objects, correct? Let's look at this. I can write code like this, class node, right? What all information I do? Let's say I want to store integer type of data. So I'm going to say int data. What is next? This needs to be referred to this again is another type of node class only, right? This will again have left child, right child, and the data. That means it is referring to what type? Again, the node type. So what will I have here? Node left. Again, I'll have what? Node right. And this constructs my class. Okay, I think this is fairly easy to understand, because if in the trees you're trying to store integer data, you would have int. If in the trees you're trying to store a string data, so here instead of integer you would write string. If you want to store, let's say, float data, so you would make basically accordingly you will turn the data structure into float. But what about this? Might be some of you are wondering, why did I write node left? Why did I write node right? Now think about this. Let's say this is your, let's take the example of, okay, let's take this is your, this is one tree. Okay, this one node, this is this. Just trying to draw a tree, but just making it a rectangle. Yes. Now, if you look at this, okay, I just messed up here. Just a second. Let's try to draw it again. And we'll have, okay, this is a tree. Now, what all information we need? We have here data. Okay, what does this mean? This means we are pointing to or you're referencing. Why I'm using the term referencing? Because I don't want you to get confused with the pointers concept. Okay, Java does not have a pointers concept at all. We are saying that this particular node, okay, this is a node of a binary tree, correct? Now of this thing, there are three kinds of information. From this node, we can go to the left child of this node. Okay, when you go to the left child, what is this child? This child itself again is of type what? Is of type node. This right child again is of type what? Node. That means you are referring, so you are basically saying you are referring to what type? You are referring to node type, correct? This is another object of the node class. Am I right? So what should I be referring this to? As node, because you are referring to another node object. This is another node object. So node left, node right. I hope that makes sense. So every node which you have in the binary tree has three kinds of information. One is the data which will store here, right? 12, 13, 14, whatever. And another thing is might be the left and the right child. Okay. Now some of you might have a doubt. What about these nodes? There are no left child and right child. So what will be the values of the left and right? They are going to be null. If you remember, null is that basically a keyword which we use in Java to, whenever you have objects, right? Objects are of which type? They are non-primitive data types, correct? Non-primitive data types basically have a default value as null, right? I do not have any. If you do not assign it to anything, that means it is null. We do not know the values. So here there is no left and right child, means the node left for this particular node is null. Right also is null because you do not have anything, right? And the data might be 8. Here the data might be 2 or something, and the data might be 13. Okay, so when there is no left and right child, that is going to refer to null because that is nothing existing. I hope this makes sense. Okay, so this is how you would basically use the concepts of object-oriented programming. Basically, use the concept of classes and objects to model your tree data structure in your code. Okay, do not worry, we'll see now in the IntelliJ how to do it, but this is the general idea. Yes, so there are two methods of representing your binary trees. One is the array representation, and the another one is basically your classes and objects. Okay, fine. Let's go to the code. You will find this code in the GitHub link which is provided, so you do not have to worry about this key where you'll find the code. Okay, now in this I have written a simple binary trees class, right? I have a public static void main, and I have another class called node, right? This is the node class where I am basically creating the node of the tree. Okay, so see here I have node left, node right, and I have decided to basically, store the integer kind of data into my tree. So I'm going to have int data, right? Now I also have given a constructor. This is a parameterized constructor. I hope you know about this. So public node int data. Okay, if you do not know about object-oriented programming, I would strongly recommend you just read up something about object-oriented programming, or even I'll be coming up with a course shortly. You can even refer to that. Please make sure that you understand object-oriented programming and then come back to the trees concept. Okay, so this is a parameterized constructor where I have basically I'm been able to set the value of data. So this dot data equal to data. Why the word this? Because I want to, this dot data, this particular data is referring to the property here, and ये जो white में है, this data is referring to the value which I'm given here. Okay, because both the names have same, I need to have a way of differentiating both. That's why I've written this dot data. This means this data which I'm using, the pink one, is basically the property of this class node. To this property of class node, I am given what value? The value which is passed to me through my constructor is what I am doing here. Okay, if not, just read up a little bit about parameterized constructor. Yeah, now going ahead, I have created my root data, right? Root data is what? A root node is nothing but the first node of my tree. So I'm saying node root. This is a variable name. You can give any variable name. Usually if it's the root node, you will give the name as root, right? Here I've used a parameterized constructor and passed in a value as 1. That means my binary tree now has the first node which has value 1. I want to go ahead and then create the left child for it. What will I do? Root dot left. Why am I able to do root dot left? Because if you see in the node class, I have a left and a right child which is basically of type node. Now here I need to create new nodes, right? New node for my left child. So for my left child, new node, and I passed the data 2. This right is nothing but new node 3. So what this is going to do is, if I want to explain, this is going to create a node. Let's have a value 1. This 1 is basically going to have, a left child, okay, which is going to have a value 2, and a right child have a value 3. Okay, and obviously they are connected between each other, okay, because this is a node, right? So this root node has, if I do root dot left, it is going to take me to this particular node. When I say root dot right, it's going to take me to this particular node. So this is what I'm achieving, right? How do I know whether it is correct, whether what I've done is correct or not? Just try to simply print it. When I say I'm just printing simple statements, root dot data should give me the value of 1. Root dot left dot data, that means I want to find out the value which is stored in the left child of my root. How do I do it? Root dot left is going to take me to the left child of the root, and uska data, that data I want, right? So root dot left itself is a node type, correct? So you are assigning a node to it. So us node mein you have a property what? Class data. So root dot left, that particular node's data I want, that is why dot data. And then root dot right dot data will give me this. Okay, let me show it to you once again on the whiteboard. Let's erase this. Okay, so what it is see, we have constructed 1, this is 2, and this is 3. Okay, I have named this is of type, each of these nodes of each of these circles are basically of type node. I have named this at root. Okay, when you say root dot left, what it means is you are pointing to root dot left is what you're pointing to this particular node. Okay, now of this node you want the data. So what this does is root dot left is going to take the Java compiler here. This is the memory location you are referring to. Of this you want what? The data. So because this is itself a node, this node has again left child, right child and the data thing. What is the you are referring to what? You want the data of it. What is the data? Similarly, when you do root dot right is going to take you to this part, right? Dot data means you're going to get the value as 3. If you want the data stored at this node, you're going to say simply root dot data, which is going to give you 5, right? So this is, I'm just explaining a little bit more because usually people get confused. Okay, if you have not done your object oriented for a long time, might be it gets confusing. So just wanted to clear it off. Yeah, so this is simple way I have created my tree data structure, right? Don't worry if this is a little intimidating. We'll be solving a lot of questions where this will become more and more clearer. Okay. Another part is which we spoke about was the array representation of binary trees. Now here, let's say I am creating a tree. Suppose if I have 3 nodes, right? We said we are going to start with index number 1. That means if there are 3 nodes, you need to create an array of size 4 because the first index, which is index number 0, we are not going to use. So I'm simply going to say tree of 1 is equal to 1. Tree of 2, I mean index number 2, I'm storing the value 2. Tree of 3, I'm storing the value as 3. Right? So for this, the parent left child will be stored at 2 into I, right child will be stored at 2 into I plus 1. Right? So same this 1, 2, 3, I have stored it into an array representation. Okay. Let's try to run binary trees. It's just going to give the values here. See, let me zoom it out. Right, so you have the root node has value 1, the left child has value 2 and the right child has value 3. This is what we were talking about, right? Yes, we just printed those values, right? The idea of this lecture is just to give you an idea, just to introduce you that a tree data structure is basically hierarchical in nature. If you want to model that, write code for it basically, then you can do it in 2 ways. You can use the concept of classes and objects, or you can do the array representation for binary trees. The most widely used when you solve problems on trees is going to be the classes and objects one. Array wala representation very rarely we use, but you should know about both of them. Okay, I hope this helps.